Okay, so in lesson 4, we're going to keep on going with that derivative rule, that product rule that we were looking at before. And we're just going to kind of manipulate it, and we're just going to apply it to different questions. Obviously, questions that are going to get a little bit more intense. Some are going to have fractions, some are going to have radicals, whatever. But nothing is really changing from that basic rule where I take my exponent, I times it by my coefficient, and then I subtract 1 from my exponent. So the sum and the difference rules is basically now, instead of just having one term, we're going to have multiple terms. And it's pretty easy, guys. If I take the derivative of something that looks like this, obviously what we're going to do is take the derivative of each individual term and then just add them together at the end. Same thing with subtraction. So if I want the derivative of that, it literally is just separate them and find the derivative of each one. So it's pretty self-explanatory. We are going to go through in this lesson, we're going to go through lots and lots of examples. So just as my kind of disclaimer at the very beginning, remember that this is for you to learn, not just listen and tune out, because I know it can get a little bit boring after a while. So just remember, stop, pause, do the questions yourself, and then just make sure that you're getting the same answer. And then just fast forward. Like if you're getting it, it's all good. All right, so use the sum and the difference rules to find the derivatives of the following functions. So I've got the derivative of this, and now remember, this is like the difference rule, where I just find the derivative of each one individually. So just take one at a time. So 3 times 5 is going to give us 15x, and then I minus 1 from that 3, which is going to be squared, minus, now remember when I have x by itself, or like just x to the power of 1, that 1 is going to come down, okay? And then the 1 minus 1 is going to become 0. So actually, if I'm just given an x, if you remember that from the last lesson, it just disappears. It just basically becomes a 1 because the derivative of that is 1. So that's it. So anytime you have an x, it's going to disappear. All right, let's take a look at b here. So now I'm looking at the derivative of this guy. Again, take them each piece. Remember, try these on your own. 2 times 4 is 8, x, and then I'm minusing 1 from that 2, which is just 1. So I'm just left with 8x. Next one, plus x. Well, remember the derivative of x is just 1. Remember, because I take that 1, I multiply it by my coefficient, which is 1. 1 times 1 is 1. And then x to the power of 1 minus 1, that's just going to be 0, so it just, again, becomes a 1. And then minus 5. Guys, what did we say about the derivative of a constant number? What is the slope of a constant? Remember, it is 0. So this is it. That's it. 8x plus 1. And that 5 just disappears. All right, so now we're going to get into ones that are a little bit more tricky, fractions and radicals, as I said. So this first one, if you guys remember from that last lesson, you don't want to take the derivative of a radical. You always want to turn it into exponential form. So remember, a half is the same as the square root, and then that's just going to be minus a half. Now, again, just the same rules apply. We're going to take that derivative. I multiply a half by 2, which is 1, so 1x, and then I minus 1 for my exponent. So remember, a half minus 1 is negative a half. And then the next one here, I've got minus a half. That is a constant. And remember, what's the derivative of a constant? 0. So this is it. Now, x to the power of negative a half, remember we were talking about how we can also make that into a positive by putting it in our denominator, and then we can also turn it into a radical again. So the final answer there would be 1 over root x. Let's take a look at the next one. 4 over t minus 1 over t squared. Again, we are going to look at fractions later and how to find the derivative, but for right now, what you want to do is convert these into a more lateral equation where you're just bringing in your negative exponents. So this would be the same as 4 times t to the power of negative 1, because right now it's a positive 1 down there, minus t to the power of negative 2. Okay, so make sure that that makes sense to you. If it doesn't, just ask somebody at the help desk really quick to go over that with you. Now what we're going to do is find the derivative. So that times that is going to be a negative 4t, and I'm minusing 1, so that's going to give us negative 2. Now I've got like a minus 1t here, right? So negative 2 times negative 1 is going to be positive 2t, and I'm going to minus 1 from that, which is going to give me negative 3. Now this could be your final answer. Again, it won't be in a solution. So what you want to do is make it into the same kind of form as what your question is, so fraction. So I'm going to have negative 4 over t squared plus 2 over t cubed. All we're doing is just moving those negative exponents to the bottom. All right, we're on a roll. Let's keep going. E, remember, please try these yourselves before you just look at the answer. All right, for E, one thing that I'm just going to kind of talk to you guys about really quickly is the importance of reducing your equation before you get started. If you look at E, it kind of looks a little bit crazy, right? You got x's all over the place. You got x in a denominator. Some of you might think, okay, I'm going to bring that x up and it's to the power of negative 1. And it's just a little bit crazy. Reduce first if you can. So if I divide everything by x, that's just going to become x squared minus x minus 1. So get rid of all of that. And now when you look at it, oh, it's way easier. So let's take the derivative of what we see here. I'm going to bring down my 2. So it's 2x. 2 minus 1 is 1. So I'm just going to be left with 2x there. Minus, remember, the derivative of x is 1. So we have minus 1. And then the derivative of a constant is 0. So it's just going to be 2x minus 1. All right, for F, we've again got kind of like a crazy looking equation. We've got radicals, we've got fractions, we've got lots of yucky things. So let's again simplify this first. So I've got my f of x equals x squared minus 2x to the power of a half. Remember I was saying let's always try and turn those radicals into exponents. And now it's going to kind of look like a more difficult version of E. Basically what we're going to do is we're going to divide everything by x to the power of a half. Okay, so we're literally dividing by that. So remember when we divide, we subtract our exponents. So this is going to be like 2 minus a half. And 2 minus a half, so it's kind of like 4 over 2 minus 1 over 2. So that's going to be 3 over 2 minus, and a half minus a half, well, that's 0. So x to the power of 0 is just going to be 1. So we're just actually left with a 2 there. So that's our simplifying done. Now what we want to do is actually find the derivative of that. So again, I'm going to bring that down. 3 over 2x. I need to minus 1 from that, which again is kind of the same as like 3 over 2 minus 2 over 2. So it'd be a half. And guys, remember, what's the derivative of a constant? 0. So I've basically got, if I want to just kind of make this a little bit nicer and put it in the same form as my question, I'm going to have 3 root x divided by 2. And that would be our final derivative. All right. So the next page is a little bit different. This is more like application. So rather than just kind of like repeat, we're applying all of our knowledge here. So at which point does the curve 3x squared minus 4x have a tangent with a slope of 2? Now remember just the key words here. At what point, so we're looking for a point, does the curve blah, blah, blah have a tangent with a slope of 2? Now remember guys, derivative equals slope. Super, super important. Derivative equals slope. So obviously the minute that you see the word slope in a question, you want to think derivative. How do I find the derivative of it? So y equals 3x squared minus 4x. Let's find that derivative. So I'm going to bring that down, 6x, and then minus 4. Hopefully you're starting to get a little bit more comfortable with those derivatives. Now, if I've got that as my derivative, remember slope is equal to 2. Well, derivative is slope, so it must be 2 is equal to 6x minus 4. And now what we have to do is solve for x. So add 4, which is 6, divide by 6, divide by 6. So x is going to be equal just to 1. Now that we've got x is equal to 1, we want to plug that into our equation because remember we want to find a point. So if I know that y equals 3x squared minus 4x, I want to look for y when x is equal to 1. Okay. When we do that, y equals 3 minus 4, so y is going to be equal to negative 1. So our final answer here would be 1 comma negative 1. So really just 3 steps. We just need to find the derivative, we need to substitute in our slope, and then we just need to solve for the point. 3 slopes every time for these questions. All right, for B, this one is, I like this question because you're going to see this again on your assignment, or in some assessments, I should say. And the key word there is horizontal. And this is actually going back, again, I've kind of mentioned it a million times, but a lot of this actually stems back from Math 10C. And you may have forgotten this. So let's read through at which points, okay, so we're looking for our points here, and we might have more than one, hint, hint, because it says an S there. So at which points does the curve, blah, 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 have horizontal tangent lines? So remember, if I have horizontal line, what have I said a few times already? If I have a horizontal line, what do I know my slope is? Remember, 0. So again, even though it's just using that word horizontal and it's not using the word slope, we automatically know what our slope is. So same rules apply. I've got my equation, y equals x cubed minus 3x squared minus 24x. Remember, obviously, we need to find that derivative because we're talking about slope here. Bring the 3 down, minus 1 from that exponent. Bring the 2 down, minus 1 from the exponent, and the x just cancels out because remember it's just going to be to the power of 1. So this is my derivative here. And the cool thing is, remember, we know our derivative is equal to 0 because our slope is 0. So that's 3x squared minus 6x minus 24. Now, if you look to solve this, first of all, what I would do is I would simplify because the only way to solve this is actually factoring. You could use your graphing calculator, but remember, you don't want to depend on that. So the first thing that I would do is I would look to see if I can reduce both sides here. And look at, I can definitely divide that side by 3 and that side by 3. And as long as you do something to one side and the same thing to the other, you can do whatever you want. 0 divided by 3 is 0, obviously, and we're left with x squared minus 2x minus 8. And now, factoring, this has gone from a PSA 2, which sucks, to a PSA 1, which is pretty easy. So now I'm just looking for the factors of negative 8 that add to give me negative 2. So negative 6 and positive 4. So I've got x minus 6 and x plus 4. And that's going to give me, 6 and 4. Who's doing this math? Sorry, guys. Negative 4 and positive 2 multiply to get to 8, and then they add to get to negative 2. Sorry about that. So x minus 4 and x plus 2. Just keeping you on your toes. And now we can solve for those x values, which is obviously just the opposite. It would be 4 and negative 2. All right. Now your head might be spinning like, okay, what are we doing? We're factoring, we're doing everything. Remember, step number 1, we found the derivative. Step number 2, we set that equal to our slope and we solved for x. Step number 3, we need to solve for our point. Now, in this case, points, because it says at which points. So I have 2 x values. I do know, I'll just do this in a different color so you can see the difference. I've got my equation, x cubed minus 3x squared minus 24x. Okay, and I've got a couple of values for my x's. So we've got to do this twice rather than just once. So I've got y is equal to 4 cubed minus 3 times 4 squared minus 24 times 4. And when you evaluate that, you're going to get negative 80. Next one, I'm going to do the same thing, but instead I'm using negative 2 squared minus 24 times negative 2. And when I actually evaluate that, we're going to get 28. So the two final answers here, or the two points, would be 4 and negative 80, and negative 2 and 28. And those would be our solutions. All right. Last two questions that we're going to do for this lesson. We've got number 3 here. So it's saying for the function f of x equals 2x cubed, blah, 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 blah. But you can see that there's an a in this, which is a little bit different. If f prime of negative 1 equals negative 6, then find a. All right, so this is a little bit different. You can see it's not saying slope. It's not saying find the points. It's saying what is a. I really like these questions because it's kind of like solving a puzzle. Well, first of all, the clue here is that you can see the derivative. So obviously, we need to take the derivative of this function. And what does this mean? Well, normally we see f of x. So if we see f prime of negative 1, that must mean that x is equal to negative 1. And that must mean that when x is equal to negative 1, our derivative is equal to negative 6. So obviously the first step, we need to find that derivative. So I've got 2x cubed, so that's going to become 6x squared minus 2 times 5 is 10, x to the power of 1. Plus, now remember guys what happens when I've just got an x, I'm just left with the coefficient, just that a, and the x is going to disappear. And then I've got minus 7, and remember that's a constant, so minus 7 is just going to disappear as well. Now that we've got this, we have to go over to our little, puzzle over here and remember that, oh yeah, well when x is equal to negative 1, our derivative is equal to negative 6. So that must mean negative 6 is equal to 6 times negative 1 squared minus 10 times negative 1 plus a. All right, so now we want to simplify and then obviously just solve for a. So we've got negative 6 is equal to 6 plus 10 plus a. Negative 6 is equal to 16 plus a. So we want to minus 16 from both sides. And a is going to be equal to negative 22. Those are so fun. I love these. All right, and the last question, B here, we're doing the same thing, but this is a little bit more intense because we've got now two variables. So it's saying for the function f of x equals blah, 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 and you can see we've got an a and a b in there this time. If the derivative, when x is equal to 1, okay, is equal to 15, so that's kind of what we did in the last question, remember? We're kind of deciphering two pieces of information. X is equal to 1, and our derivative is equal to 15. And we've got another one now. X is equal to negative 1. Our derivative is going to be equal to 23. So basically, we just have to do double the work here. And then a little bit of equation solving. So again, obviously, the first step is going to be, let's solve for that derivative. So 4x cubed plus, remember that 3 needs to come down, so we're actually going to have 3a x squared plus 2b x minus 2, and that 12 is just going to disappear. Okay, I know I'm going a little bit quicker with those derivatives, so if this is too fast for you, make sure just pause it, maybe do a little bit of practice, and then come back to these. All right, so let's take a look at my first equation there. I know that 15 is equal to everything when x is equal to 1. Okay, and obviously now we just want to simplify this. So I've got 15 is going to be equal to 4 plus 3a plus 2b minus 2. So 15 is going to be equal to 2 plus 3a plus 2b minus 2. So 13 is equal to 3a plus 2b. So that's important, but obviously not our final answer. Remember, guys, again, back from 10C, whenever you've got two variables, you need two equations. So let's come up with our other equation using this information here. So I'll just do this one in a different color. Okay, so again, our derivative we've got up here, and we know that our derivative is equal to 23 when x is equal to negative 1 cubed plus 3a negative 1 squared plus 2b negative 1 minus 2. Simplify again, so we've got 23 now equal to negative 4 plus 3a minus 2b minus 2. All right, now if I bring everything over, I'm just going to kind of add 4 and add 2 to the one side. So that's going to give me 29 is equal to 3a minus 2b. And so that is my other equation. Now, how do I solve two equations? It's crazy how often students forget how to do this. My favorite method is the elimination method. You could use substitution. You could use graphing, though that's not recommended in calculus. But yeah, my definite favorite is elimination. So you just put one of your equations on top of the other one, and you eliminate any variable that you want. And we're lucky because our coefficients are the same. So let's say that I want to eliminate my a's. Doesn't matter, I could also eliminate b's. But basically, how do I say 3a and 3a? How do I get rid of them? Well, we would minus. 3a minus 3a is going to cancel. Then I have to subtract everything. So 13 minus 29 would give me negative 16 equals 2b minus negative 2b would become 4b, because it's kind of like 2 plus 2. Then I would just divide by 4, and b is going to be equal to negative 4. So this is one of our answers, which is awesome. Now all we have to do is solve for that a, and you can do that by substituting this into either equation. It doesn't matter. So let's just take the first one, whatever, doesn't matter. 3a plus 2b, okay? So that's now going to become 3a plus 2 times negative 4. 13 equals 3a minus 8. So obviously we're going to add 8 to both sides. 21 is equal to 3a. Divide by 3. A equals 7. I love these questions. So fun. All right. Now, guys, you need to practice this. Okay, so right here, obviously page 88, go through, double check, check the solutions, and have fun.